got another great talk coming up next. It is going to be given by Eden Ruffel. She is a PhD student at UCL. She's an honorary fellow at Moorfields Hospital, and she holds a number of other positions where she is currently investigating how we can build foundation models using sensitive informations about the eyes, and then so the downstream task can start to automate, important types of detection of diseases, perhaps delivering those results to people much faster and more accurately that can be done by humans alone. We've been working with her for quite a while as she is trying to transition that type of training process to be federated. And so I've been incredibly impressed with the results she's achieved so far, and I can't wait to see where she's got to now. Over to Eden.
Thank you very much. Let me just figure out how to share my screen, and then I'll kick things off. This is classic technical difficulties. You would think with a room full of computer scientists, they'd figure out how to do this, but maybe not. What do I need to do?
You go mirror and then choose content.
Ooh. Here, I want to share this screen.
Yeah, great. So go extended.
And then do I just drag it?
Sure.
If I can figure out where it is.
There you go.
Oh, I had it.
You can mirror. That's helpful.
No, I'll do this. It should be fine. I just need to see in the distance my tiny cursor. I cannot see where my screen is. Okay. Brilliant. Okay, fabulous. We're making it work. Hi. Thank you so much. My name is Eden. Thank you very much, Nick, for inviting me to speak today. As mentioned, I am a PhD student at UCL, so I'm actually in the first year of my PhD. So the work that Nick was referring to earlier was actually during my master's, so be nice. I'm also an honorary research fellow at Moorfields. So as part of my my research group, my supervisor is Professor Piers Keane, who is a consultant ophthalmologist at Moorfields. And as such, I primarily use eye data. So we're using that to build these foundation models. And again, as Nick mentioned, we're using foundation models and trying to see how we can apply federated learning to the fine-tuning of that. So I'll talk about that a bit more later. So in addition to my role as a PhD student and honorary research fellow, I also am a data scientist and researcher at an organization called Insight, which is an NHS-led initiative that helps to make anonymized data available for researchers, both at the hospital but also elsewhere, in a really safe way. So we take the data from, for example, a hospital like Moorfields, we make it nice and tidy, we clean it, and then we make it available. And at the moment, the Insight data set that we have is the world's largest ophthalmic imaging bioresource with over 24 million eye images, 2 million patients represented, and this infrastructure is allowing us to take advantage of this data and validate the sort of cutting-edge AI tools that myself and others are developing at UCL and at Moorfields. And one example of the things that we've managed to do with this data is develop the world's first retinal foundation model. I'm sure a lot of people in the room know what a foundation model is, but I'll be generous and explain a little bit. Essentially, a foundation model, at least a vision foundation model here, learns generalizable representations from vast amounts of unlabeled images. The RetFount model specifically, which we published in Nature in 2023, uses both fundus photography. So if you've ever had an eye test, that was a fundus photograph, and you can see that's actually my eye just there at the top. Also OCT, so that's ocular coherence tomography, and those are 3D eye scans. It's essentially a bit like an ultrasound, and you can see the back of the eye through the retinal sublayers. I'm not a clinician, so don't ask me any more questions about eyes. I'll refer to other people in the audience who have much better specialties than me. And with this foundation model, we were able to then take those generalizable representations that we've learned from these images of eyes, and then fine-tune them, so adapt them for lots of different downstream tasks, whether that be predicting eye disease, like diabetic retinopathy, or predicting systemic disease in a field that we like to call oculomics, which is essentially using eye images in order to predict systemic health conditions. So whether that's predicting heart attack or neurodegenerative diseases like Parkinson's from eye diseases, that's something that we are trying to do with these sorts of models. However, although we have this very large amount of data, it is only coming from a single institution. So we're kind of limited about the sort of power that these models can actually imbibe within them, because we are only using data from a single source. So this sort of led me to think, when I first joined my research group kind of just over a year ago, and when I was starting my master's project, what is kind of the next step for these large foundation models? How can we access more data? Federated learning, which is why we're all here today. So trying to think about how we can introduce federated learning into the development cycle of these foundation models was something that really interested me for many different reasons. Where exactly we can introduce federated learning can happen primarily in two areas. So either the pre-training, so that part I talked about just now, where we're using these unlabeled images to train the base model to give it that foundation of knowledge. But then also at the fine-tuning stage, so when we've got this base model and we want to then apply it to lots of different tasks. So as I said, whether that's predicting whether a patient will go on to have dementia. And in healthcare especially, this is really helpful for three main reasons. Collaborating with other hospitals is very challenging because there are a lot of data governance issues, strict IG, that have to be overcome in order to actually make those collaborations happen. And having only worked in this field for a year, it's been very challenging to work with other hospitals for these reasons. But if we can use something like federated learning to help develop these larger models in this way, then this would be great. It would also enable us to have much broader data sets that are from a wider, diverse population. So this helps to improve the health equity of these models so that they can actually serve a wider audience of people, maybe underrepresented populations. And then we also we can spread the computational benefits as well. So if you have a smaller hospital, then you're likely not going to be able to have lots of computational resources, so we can spread that around. So my research, as Nick said, has been primarily about taking the foundation models that we've developed and fine-tuning them using Flower, which has been amazing. And I really like all of the framework updates as well. It's made my life way easier. And the reason why we were able to do this with real federated data is we have this data set that we call ALZI, which actually comes from lots of different hospitals that are within the Moorfields network. And we have this data that comes from around 350,000 patients, that's taken from around 10 years. And we've been able to link their imaging that they've had at Moorfields to systemic health data. So from there, if you've ever gone on to, when any of the patients have gone on to go to hospital in A&E or admission or have an outpatient appointment, we can look at why that happened and then link it to their imaging. And in this way, we can have clients in a federated learning setup that are truly distributed, and the data that is within each client is coming from only one of those single institutions. So we have very varied sizes of the clients, but also very different distributions of the patients that are represented in those clients because of the locations that they're coming from. Most recently, I've been developing, fine-tuning a new foundation model that we've developed, which is a version of RepFound pre-trained using DynoV2, which is a kind of very popular methodology for pre-training foundation models, especially in the medical sphere, specifically to go on to predict, using eye scans, predicting whether a patient will go on to have a heart attack, using around 1,400 patients overall, the whole network, but using clients that have very different sizes. So the smallest having just over 100, but the largest only having 1,300. So still not huge numbers. And very briefly, because I know I'm really running out of time here, what we found, and this is again very exciting, is that the centralized model, when we compared it to a model that's been trained over 5 server rounds, that there was no difference really in the performance. And this was just using the very straight out of the box federated averaging. So that's really exciting that we know that this is possible, that training foundation models using federated learning for the fine-tuning works. And the only significant difference really in the performance was when we had kind of more of a zero-shot approach, where we just did one aggregation and we compared that to a centralized server. There was a difference, so more rounds essentially allowed the model to learn more. And we also validated our outputs using a large data set called UK Biobank. And although overall the performance is degraded across all the models, we again didn't see any significant difference between the server model that is trained for 5 rounds versus the centralized model. I won't go into too much detail because I'm really running out of time, but we also looked at the equity of how the larger clients performed versus the smaller clients. So from left to right, it's the largest hospitals, and on the right, we've got the smallest hospitals. We saw that for the larger hospitals, the performance when only trained on its local data versus the kind of being part of the federated learning strategy setup, was definitely an improvement, but it wasn't a drastic improvement. For the sites that had kind of mid-level of numbering of patients, we saw a slightly larger improvement. So this again highlights the importance of these smaller hospitals benefiting from being part of a federated network. And the smallest hospitals saw the largest improvement. So when only trained on their local data, you can see that they don't do very well at all. But when trained in the federated network using all of the accumulated data, those clients actually did really well on their data. In the future, we're looking to focus more on that pre-training aspect, and I have active collaborations with people in the University of Washington, University of Colorado, trying to see if we can implement some of these federated strategies at the pre-training phase. And I'm also working with colleagues in the Institute of INEA at Harvard University, seeing if we can deploy just some of these very, very straightforward federated learning frameworks to train some of these foundation models using their data in addition to ours. So that's really exciting. Any questions? Thank you very much.
Thank you, Eden. We have time for 1 or 2 quick questions. Right down in the front here.
Hi, thank you. That's really nice work and a nice talk. So the hospitals in your network, do they have compute infrastructure in the hospitals? And my second question is, presumably this is sensitive patient data, so do they require any privacy guarantees around the model weights that are being transmitted between the server and the client?
Mm-hmm. So to clarify, so the data, although it's coming from separate places, because it's part of the Moorfields network, it's actually all in one single location. What we wanted to see with these experiments is if these clients were actually separate, would it still work, despite already having a single kind of data set that we've got accumulated? But yes, absolutely. With patient safety, we would have to, if we were going to do this in a real world setting with the data actually being distributed and trained in a distributed way, we would have to consider additional privacy mechanisms. And the changes to the Flower framework have made sort of setting that up very simple. One of the challenges, obviously, working in healthcare is making sure that not only do each of the different hospitals have the kind of compute resources, but also the technical understanding in order to set up the privacy infrastructure. So there's always struggles with that. Thank you.
Great. Let's take one more question just from Sophie. I think she did. Just here.
Hi, yeah. So other than the obvious issue of data privacy, what other potential obstacles have you had to overcome really implementing this in the real world?
So implementing this in the real world, so as I mentioned, some of my collaborators that I've been working with been doing this for kind of just under a year, and these processes are very slow. So the governance is still very challenging in the healthcare sphere, despite people understanding what federated learning is and understanding that there is definitely this separation where data is not being moved. A lot of active collaborations, at least when we're trying to come up with research projects, still require the governance that as if the data was actually being moved into a single location, which makes it very frustrating because we're trying to show that we don't need to do this, but they want the safety net there just in case. So that's been a challenge. So things are very slow moving. So this is why we wanted to initially show that it was feasible with data that we had access to that is truly distributed. But then we're moving to actually working with others. It should be quite straightforward. It's just a case of having the infrastructure set up. One of the other challenges that we've seen is obviously different institutions store their data in different ways. They have different resources in terms of the compute that they have. So obviously working at somewhere like Moorfields, collaborating with institutions like Harvard, they have great resources. But if you want to integrate working with other smaller institutions, they might not have that same power of resource or data. So that's been another thing that we've been contending with. Thank you.
Great. Let's thank Eden again.